So here we have question 4 of the 2011 physics test, and this question is about circular motion. So straight away when you think of that, you need to be able to go to your data booklet and say, okay, so we're going to be working with these formulas. If I'm dealing with force, remember that we have F is equal to ma, so F for circular motion is going to be mv squared over r. You need to be able to work with these. Your force always here for circular motions is your centripetal force, and that is the force towards the center of motion. So your motion is going around in a circle, and your force is always towards the center, and your acceleration is always towards the center. Okay, so let's read the question. It says, a linear spring of negligible mass requires a force of 18 newtons to cause its length to increase by 1 centimeter. The sphere of mass 75 grams is attached to one end of the spring. The distance between the center of mass M and the other end P of the unstretched spring is 25 centimeters as shown below. The sphere is rotated at a constant speed in a horizontal circle. So it's a constant speed. So therefore all the force will be towards the center, center P. The distance PM increases to 26.5 centimeters. So explain why the spring increases in length when the sphere is moving in a circle. Now when it's 25 centimeters, this spring is exerting no force. And that force that you need to come, because the centripetal force needs to go into the center, when it's turning in circular motion, to cause that circular motion, there needs to be an inward centripetal force. So to get that force, the spring has to extend a certain amount in order for it to exert this, whatever the length, extra length is, 18 newtons per extra length. Okay, hope that makes sense. Because it's going in circular motion, there needs to be this force coming in, and therefore the spring needs to extend in order to provide that force, that centripetal force. Then it says determine the speed of the sphere. Now, firstly, you've got a whole lot of unit issues here. You've got 75 grams, you've got 25 centimeters, you've got 18 newtons. You need to make sure that these are all in your SI units. So you've got 0.075 kilograms. You've got 0.25 meters there. And over here, 26.5 centimeters, 0.265 meters. So please make sure that you put everything in because you're dealing with newtons. You see, your newtons is a kilogram per meter per second to the -2. So everything, all your data, that if you're going to be using newtons, all your data needs to be in SI units. Then you need to identify your formula, which is this one over here. The force is equal to mv squared r. Force is equal to mv squared r. Now, what is the force? Well, we're told it's 26.5, so there's an extension of 1.5 centimeters, and that will give, because it's 18 newtons per 1, we know that this is going to lead to a 27 Newton force inwards. Is that clear? I hope that's clear. 1 centimeter corresponds to 18 newtons. 1.5, you're going to find half of 18, which is 9, and you add it to 18 and you get 27. So you've got 27. Let me just erase that. So you've got 27 newtons is equal to your mass, which is 0.075 times your v squared, which you're trying to find out, divided by your 0.2665, which is equal to your which is your radius. So you need to change that, the subjects of the formula. So I'm going to have 27 times 0.265 equals divided by 0.075 equals, and then I find the square root of that, and I get my velocity is equal to 9.76. And I see here all of these are I get one significant figure there. I've got two significant, well, I've actually got three significant figures there. So I could put 9.77 meters per second to the minus 1 there. That will give me my velocity. Okay.